Hi everyone, so I've been having my exams this week and tomorrow happens to be the mathematics exam, so I thought it would make sense to make this video for those of you who need it. So I have two things to say before we get started. So firstly, this video isn't going to cover all the topics in year 8, it's just going to cover a few listed over here. And secondly, this video is not going to be in depth at all, and what I mean is that I won't be going over a lot of the proofs and the deep explanation in this video. With that being said, let's get started. So the first bit is about expression. So we have two brackets that we have to expand. So remember when expanding brackets, the key thing is that you're taking the thing in front of the bracket and then you're multiplying it by the two terms over here like that. So firstly, we have to take 2x and multiply that by x. Remember 2x is just 2 times x. And when we multiply that by x, you have x times x over here, and x times x is just x squared. So in other words, we just have 2 times x squared for that part. So we have 2x squared firstly. And then next you want to take 2x multiplied by -5. So remember that the sign in front of the number should be taken into consideration as well. So we're taking 2x and then we're multiplying it by -5. So in this case, you're taking 2 times x times -5, and you can multiply the number terms. So 2 times -5 gives you -10, and you still have to multiply that by x. So that gives us -10x. So, so we have that, and then minus 10x. And that is the answer for the first question. The second question is a little bit more complicated because we have a square. But remember, what a square is, it's basically just multiplying the thing that's being squared by itself twice. So what that means is that we're taking the thing inside the bracket here, which is 3x plus 5, and then we're multiplying this by itself. So that's 3x plus 5. So we have a double bracket here to expand. Now don't be scared of double brackets. It's really the same as single brackets. You're just taking the thing in front and you're multiplying it by the two terms. The only thing different now is that there are extra steps. So firstly, you're going to be taking 3x and then multiplying that by the stuff in the bracket, which is 3x plus 5. And then you have to add 5 times the thing in the next bracket, which is 3x plus 5 again. Once you've done that, you can do the same thing that we did before. So 3x times 3x, 3 times 3 gives you 9, and x times x gives you x squared, so that's what we get first, plus 5 times 3x, 5 times 3 is 15, and then you're multiplying it by x, so you get 15x. Next we have 5 times 3x again, so that just gives you 15x once again, and then 5 times 5 is just 25. And all of them are positive in this case, so we don't have to worry about negative signs. One last step is that notice that these two terms are like terms, both of them are x terms, so we can combine them. What I mean is that the final answer we get is 9x squared plus 15x, which is 30x, and then plus 25. Okay, so that is the answer for the first question. Now let us move on to the second part, which is solving equations. I only have one question here for you, but then this question should be a good enough challenge for year 8. So we want to solve for x. Now remember, the first thing is that you want to identify whether there are squares or fractions. If there are squares, you get rid of the square via square root. If there are fractions, you get rid of the fractions by multiplying. So the fraction is basically just dividing. So on the left hand side, we're taking 3x plus 2 and then the whole thing divided by 5. So if I divide by 5 and I multiply by 5 again, so if I take that, multiplied by 5, well then I get rid of the fraction and I'm left with 3x plus 2. But of course I can't just multiply 5 on one side, I have to multiply 5 on the other side as well. So notice that by multiplying 5 on the other side here, I get this little bracket over here, which is 5x and then plus 6. And then that's still over 9. So I have to expand the bracket on top first. So expanding the bracket on top, 5 times 5x is 25, and then x, and then 5 times 6 is 30. So we have 25x plus 30 on 9. Okay, let me get rid of that real quick. So we get that this is equal to 25x plus 30 on 9. Now we're not done with the fractions yet because there's another fraction on the left hand side. Sorry, on the right hand side. So again, you just want to multiply by 9 and that gets rid of the fraction for you. And again, you can't just multiply 9 on both sides. No, sorry, not just on one side, you got to multiply it on the other side as well. So on the right hand side, you are left with just the numerator 25x plus 30. On the left hand side, you just want to multiply out this bracket. So 9 times 3x gives you, 9 times 3 is 27, and then x. And then plus 2 times 9, which is 18. So that's what you get. Now we are not done, we still have to solve for x by itself. So first thing I want to do is I want to get all the x terms on one side and all the number terms on the other side. So let me start off by subtracting 25x from both sides. So subtracting 25x on both sides, that gets rid of the 25x over here, because you're adding 25x, subtracting 25x, so it cancels it out. Let me continue over here. So we have 27x minus 25x, that obviously gives you 2x. And then you have plus 18, and then that's equal to 30. So again, we want to isolate the x by itself, so we subtract 18 from both sides. Excuse me. So over here, plus 18 minus 18 cancels each other out. Left with 2x, that's equal to 30 minus 18, which gives you 12. So 2x is just 2 times x, so to get rid of the 2, we just divide by 2 on both sides. So over here, you're multiplying by 2, dividing by 2, that cancels out. You're left with x here, and that's equal to 12 divided by 2, which is 6. So that is the answer for this bit. Let's move on to the next bit, which is rearranging formulas and substitution. So firstly, we want to make v the subject. So firstly, we need to know what this question wants in the first place. This question wants us to find out what v is equal to. So it wants us to write this equation in the form v equals to something. So how do we do that? Let me rewrite this equation down first. So we have u is equal to 4v squared plus 5w. So you just want to isolate the v term by itself now. So we can start off by subtracting 5w on both sides. So we minus 5w and then minus 5w. So on the right hand side, you're adding 5w and then subtracting 5w, so that cancels out. On the left hand side, you are left with u minus 5w. There's no cancellation here because they aren't like terms. And that's equal to 4v squared. Now the next thing we want to get rid of is that we want to get rid of the 4, since the v squared should be done first, so we have to get rid of the 4 first. So you can divide both sides by 4 to cancel that 4 out. Because since you're multiplying by 4 and then you're dividing by 4, so on the right hand side this 4 cancels out. So again, let me just bring this up here. So that leaves you with u minus 5w on 4, and then that's equal to v squared. So now to get rid of the square, all we have to do is square root both sides. So by square rooting both sides, we cancel the square on the right hand side. And remember, whenever you're doing square roots, you have to put down the plus minus sign, just like that. So our final answer, we get the v is simply equal to positive or negative square root of u minus 5w divided by 4. And that is the answer. So the next bit is a continuation of the first bit. So we want to find the value of v when u is 59 and w is negative 1. So this is substitution. So we know that this is the formula that we use to find v. So all we have to do is we have to plug in the values of u and w to find the value of v. So let me just rewrite down that same equation, but with the terms inside. So the plus minus square root of u, and u is 59, minus 5 times w, and w is negative 1. So we have 5 times negative 1, and then all that divided by 4. So let us start off by doing this part. So 5 times negative 1 gives you negative 5. So let me just write that down real quick. That gives you negative 5. So we have a minus and then a minus 5 inside. And over here, because we have a minus minus over here, a double negative, so that becomes a positive. So we are left with the plus minus root of 59 plus 5 divided by 4. Oops, oh my goodness, sorry. Okay, so now the next bit is that we take 59 plus 5 over here. 59 plus 5 gives us 64. So we have 64 on 4 and then the square root on the outside. And then you do what's inside the square root. So 64 divided by 4, that gives you 16. So we have the plus minus root of 16. And the square root of 16 is simply 4. So we have plus minus 4. And the square root of 16 is 4 because 4 times 4 is equal to 16. So that is the solution for this question. It's positive or negative 4. Next, let's move on to linear simultaneous equations. So simultaneous equations are relatively challenging for this level, but there's nothing to really be afraid of. So firstly, what this means is that they're giving us two equations over here and two terms. So we have to solve for both x and y in this case. So let me just write down the equations here first. So we have 5x plus 2y, and that is equal to 25. And we also have 2x minus y is equal to 1. Okay, so what I'm going to do is I'm going to take the second equation first because that looks easier. I'm going to take the second equation and I am going to isolate the y by itself. Forget erasing that, sorry. So I want to isolate the y by itself. So I'm going to take equation number 2 and rearrange it. So I can subtract, not subtract, I add y on both sides firstly. By adding y on both sides, on the left hand side you have a minus y and then plus y, so these cancel out. You're left with 2x over here, and that's equal to 1 plus y. And you just subtract 1 from both sides to isolate the y. So since over here you have a plus 1 and then a minus 1, so they cancel out, you are left over here with 2x minus 1 is equal to y. So we know that y is equal to 2x minus 1. So now we just take equation number 1 over here and we substitute in that value of y. What do I mean? So we have 5x and then plus, instead of 2y, since y is equal to 2x minus 1, we just put that in the brackets as well. So we have 2x minus 1. So I'm just substituting y into the y value there. So I'm substituting 2x minus 1. That is still equal to 25. Now we just have to expand the brackets. So we have 5x plus 2 times 2x is 4x. And then minus 1 times 2 is 2. And that gives us 25. And we just need to simplify this. So we have 9x from combining these two terms. And then I just need to plus 2 on both sides. So plus 2, which cancels out the minus 2 on the left hand side. And that leaves us with 27 on the right hand side. And we can just divide both sides by 9 now to cancel out the 9 on the left hand side. So that gives us x is equal to 3. And now, knowing that x is equal to 3, you just need to put in x into one of these equations. So let's pick equation number 2 again. So I'm just going to make this really quick. We have 2x plus y is equal to 1. We know that, right? And since x is equal to 3, you have 2 times x, which is 3. That gives us 6 plus y is equal to 1. So in this case, y has to be, no, sorry, not plus, sorry, minus. No wonder I sent something wrong. It should be minus there. 6 minus y gives us 1. So that means that y has to be equal to 5. Okay. So that is it for linear simultaneous equations. Next, let's take a look at factorization. So we want to factorize the first bit and then factorize the second one. Okay, so for the first one, this one's slightly simpler. All we have to do is find the highest common factor first. So the highest common factor of these two terms, you have to look at the terms one by one first. So you take a look at the numbers in both of them. 6 and 15, what's the highest common factor? So the highest common factor of both of these is 3. Okay, now let's take a look at x, and for the second term there is no x. So we know that the highest common factor does not include an x. Now let's take a look at y and y squared. The highest common factor of y and y squared is y. So we know the highest common factor is 3y. So now you just have to put 3y and then a bracket. So factorization is the opposite of multiplication. Sorry, not multiplying out brackets. So over here, you need to find out what multiplies with 3y to give you 6xy. And one of the simplest, most straightforward way of doing this is using this method here, which is just using a long division. So you do whatever is given, and then you want to divide it by 3y to get what's inside the bracket. So now let's take the first term first, 6 and 3. So 6 divided by 3 gives you 2. And then you have xy divided by y. So since the y's, they cancel each other out, and the x's remain there. So we have 2x, just like that. So 2x times 3y gives you 6xy. So we just need to subtract that, and then it cancels out nicely, so we have just 15y squared over here. So we put a plus sign down. 15 divided by 3 gives you 5. And then y squared divided by y gives you y. So you have 5y, just like that. So our final answer is 3y, and then multiply it by 2x plus 5y. So that is our final answer for the first question. The second question is a little bit more complicated because we have to do factoring by grouping. So what factoring by grouping is that you want to group these two and then these two. So we're going to factorize the first two first, and I won't go through the division again. So we just take out the highest common factor, which is x squared in this case, and then that multiplies by 2x minus 1. So that is factorizing these two terms first, so you get that. For the last two terms, there really isn't much to factorize, so let's just leave it as it is, minus 2x plus 1. So something about factorizing by grouping is that you want the part in this bracket to be the same as whatever is in that bracket if you factorized it. But in this case, notice that it really isn't the same because you have 2x minus 1 on the left hand side, and on the right hand side you have minus 2x plus 1. But this problem can be solved because only the signs are reversed. So what we can do is that, so firstly we leave the left hand side as it is. And for the right hand side we can factor out a negative 1. So negative 1 times 2x gives you negative 2x, and negative 1 times negative 1 gives you positive 1. So we can do that. And now over here, notice that we have 2x minus 1 and 2x minus 1 in the bracket. So that is perfect. So now all we have to do is we have to do a substitution. So we say that c is equal to, say, 2x minus 1 in this case. So since c is equal to 2x minus 1, instead of this 2x minus 1 here, I can replace that with c and c. So I have x squared c minus 1 times c. So that's just minus c. And in this case, we can just factor out the c like we normally do. So we have that is equal to, you factor out the c, and then that is x squared minus 1 inside the bracket. But of course, c didn't exist in the original question, so we have to substitute this value back in. So that gives you 2x minus 1, which is c, and then multiplied by x squared minus 1. So that's our final answer. Now, I should mention that you can factorize this further, but I think for year 8, you won't really need to do that. But just for the sake of it, I'm going to tell you that this is also equal to 2x minus 1, and you can further factorize this as x minus 1, and then times x plus 1. But like I said, for year 8, you probably won't need to do this extra step. But that's factorization by grouping. Next is graphing. So, using the table to help, you have to plot the graph y is equal to 3x minus 1. So firstly, we have to fill in this table to help us out. So how this works is, again, we just do substitution. So we know that y is equal to 3x minus 1. So when x is equal to 0, all we have to do is we have to put in the value 0 in here and solve. So 3 times 0 is just 0, so that doesn't matter, and we have a minus 1. So y is equal to minus 1 over here. You can do the same process for these and you would get 2 and 5. So now we have to plot the points on the graph. So our first point over here is 0, negative 1. So let us plot down the point 0, negative 1, which is right here. Next is 1, 2. So 1, 2 is again right over here, and 2, 5 is right over here. So once you have a few points down, you realize that they lie on a straight line, and you can just draw a straight line through those points. Sorry, my line is really ugly, but then it's just a straight line through all these points. Let me try that again. So just draw a straight line through those points, and then that is the graph that you've plotted. So before we move on to the next bit, there are a few things that I would like you to notice. So firstly, wherever x is equal to 0, so this value here, when x is equal to 0 and y is equal to negative 1, that is right over here, and this is the place where this graph crosses our y-axis over here. So negative 1, which is the y value, is our y-intercept. So this over here is our y-intercept. So 0, negative 1 is the y-intercept. Let me just write that down for you. So that's the y-intercept. So that's the first thing to pay attention to. Secondly is the gradient of the graph. What is the gradient? The gradient is the slope. So the slope of the graph is for every x unit the graph moves, how many y units it moves. So what you have to see is that over here, the x is increasing by 1, increasing by 1. So for every x unit it moves up, the y increases by 3. Notice that? So because you're taking 1 and then you have to add 3 to get to 2, and then you add 3 to get to 5. So the gradient over here is equal to 3 because that is the term-to-term rule for the y values when x increases by 1. And why is the gradient of this graph equal to 3? It's because of this 3 over here in the original equation. So since it's 3x, that means our gradient is equal to 3. And then the last thing to realize, which is going to be very useful in the next slide, is this format over here, that y is equal to 3x minus 1. So notice for a straight line graph like this, when the sequence for the y function is just adding 3, adding 3, adding 3, which is just adding by the same number, the format for that is just going to be the term-to-term rule, which is in this case 3, times x, and then minus 1. So just keep that in mind. That's probably a bit confusing, but then I'll clear things up in the next slide. So over here, we want to find the term-to-term rule of this first, and that's fairly simple. Term-to-term rule is just plus 5 in this case, right? So we're just adding 5 to get to each term. So the term-to-term rule is simply plus 5. So this is what I was talking about earlier, which is the position-to-term rule. So the position-to-term rule is always going to be in some form mx plus c. So whenever the sequence is just adding by a constant every time, the position-to-term rule is always going to be mx plus c. What is x? X is basically the position number here. So that means that if this is our function, then x here would be equal to 1, 2, 3, 4, 5, and so on. So we're just mapping the x to the y. If I call this y, you can see how this relates to our table earlier. Let me just write that down for you. So you want to figure out what mx plus c is equal to. Firstly, what is m? Like we investigated earlier, m is just the term-to-term rule. So in this case, m would just be equal to 5. We have 5x plus c. Now how do we find c? We can find c using a substitution. So what I mean is that, let us say that, so y is equal to 5x plus c, that's what we know. Let's say that x is equal to 1 for now. So 5 times 1 plus c, and when x is equal to 1, notice over here that y is equal to 7, so I'll just put that down as well. So we have 7 is equal to 5 times 1 plus c. 5 times 1 is obviously just 5, and after we subtract 5 from both sides, this one cancels out because plus 5 minus 5, and then on the left hand side you have 2, and that's just equal to c. So we found out that our position to turn rule is just 5x plus c, which is in this case 2. So that's the answer to this question. Now if we want to find the 100th term, all we have to do is let x be equal to 100. Since x is the position number, when we let the position number equal 100, we get the 100th term. So how does that work? We take our 5x plus 2 from the previous question, and we just put in 100 into x. So that means 5 times 100, and then plus 2. So 5 times 100 is 500, and plus 2, that gives you 502. So that is the answer to this question. Now this is our last topic for this video, which is unit conversion. So we're going to take a look at a couple of different types of unit conversion just so that you get comfortable with it. So number 1 is convert 1 meter cube to cubic centimeters. No, sorry, not cubic, square. So a square meter to square centimeters. How do you do that? So 1 square meter is just 1 meter times 1 meter, right? So imagine a square that has sides 1 meter, 1 meter, right? When you take 1 meter times 1 meter, you get the area 1 meter squared. So we have 1 meter times 1 meter, and we convert that to centimeters. So it's important to split it up like this first so that it's easier for us. So now we can just turn them to centimeters one by one. So 1 meter is just 100 centimeters. And 1 meter is again 100 centimeters. So you take 100 times 100, that gives you 10,000 square centimeters. So that's the answer for the first part. So now for the second part, we do the same thing but kind of like in reverse. So we have 8,000 cubic, sorry, not meters, millimeters, cubic millimeters. So this is the same as saying 8,000 millimeters times 1 millimeter times 1 millimeter. And now we just convert them one by one. So for the first part, we have 8,000 millimeters, and to convert to centimeters, we just divide the number by 10. So this gives us 800 centimeters. And then 1 millimeter is just 1/10 of a centimeter. So we have 1/10 of a centimeter, and then 1/10 of a centimeter again. So you can either plug this into a calculator or you can do it by hand. But finally, you will get that the answer is 8 cubic centimeters. So we know that 8,000 millimeters cubed is equal to 8 cubic centimeters. The next one is fairly simple. 10 square, no, sorry, that's a typo, it should be cubic. Cubic centimeters to milliliters. So just keep in mind that a milliliter is literally just a cubic centimeter. So 10 cubic centimeters, that's just equal. So 10 cubic centimeters, that's just going to be 10 milliliters. So these two units are basically the same, milliliters and centimeters cubed. And for our final question, a car travels 36 kilometers in 1 hour, and we want to find the speed in meters per second. So keep in mind that the final unit is meters per second. So the formula to find the speed of an object is the speed is equal to the distance divided by the time. So in this case, our distance is just 36 kilometers, and then our time is 1 hour. So we have 36 kilometers per hour. Now we want this in meters per second. So how do we do this? Let us start off by converting the kilometers to meters. So 36 kilometers in meters is just 36,000 meters. And then 1 hour, just remember that 1 hour is equal to 3,600 seconds. So now by either using a calculator or you can do it by hand again, you get that this is equal to just 10 meters per second. And with that, we are done with the video. I hope that it's helped you out. I'm sorry for stuttering so much and saying so many wrong things, but if you made it this far, really, thanks, and I really appreciate it for watching this far. Leave some comments if you have any questions, and if you're taking exams tomorrow, best of luck. See you next time. Bye-bye.